Hey guys, we are now going to solve code forces 1987B K-sort. In this question, we will be given an array of size n and we can perform an operation any number of times. So in one operation, we can choose a number k between in the range of 1 to n, and after choosing k, we have to choose k numbers from the array. Let's say we have an array like of size 5 and we can choose k any number between 1 to 5. Let's say we have choose k equals to 3. Then after that, we can choose any three numbers from this array. Let's say we have chosen this, and this number. After choosing these numbers, we can add 1 to all these numbers. Then in these positions, the number will be incremented by 1. The cost of performing this operation is equals to k plus 1. So one operation costs k plus 1 coins. Our final goal of this question is to make the array into non-decreasing order. Non-decreasing order in the sense it can be either strictly increasing or the numbers can also be equal. So let's take an example to understand this. Let's say we have an array of size 5 and the numbers are 2, 1, 4, 7 and 6. Now to make this array into a non-decreasing array, one thing we are sure is that we can only add 1 to those numbers. So adding numbers means we can only increase the value of those numbers, but we cannot decrease the numbers. So the first element is 2 and second element is 1. Now we have to increase this 1 to match this 2, because we are told that we have to make the array into a non-decreasing order. Since we are also told that we have to make minimum number of operations, I mean the cost should be minimum. So instead of making this, we can also make this equal to 3 or 2, because 2 1 4 or 2 to 4 or 2 3 4, both of these are non-decreasing order. So to keep our cost minimum, we will increment this by 1 to make it 2. Now this is 2 2 and 4, this is in increasing order. 7, still it is in increasing order. 6, now it is decreasing from 7 to 6. Now we have to increment this 6 to match 7. So we will increment this by 1. So our final array will be 2 2 4 7 7. This array is now in non-decreasing order. What are the operations that we have done? We have incremented this number and this number by 1. So we can do this in many ways. First of all, we can choose k is equals to 1, and that the one number that we'll be choosing is 1. We will be incrementing this 1. So the cost of this operation is k plus 1, that is equals to 2. And similarly, once again we will choose k is equals to 1. This is operation number 1. And in our second operation, once again we will choose k is equals to 1. This time we are choosing this number, and the cost of operation is again k plus 1, that is equals to 2. So the total cost is 2 plus 2, 4. And with the cost of 4, we have incremented both 1 and 6. And this is approach 1. We can also do in a different approach. That is, okay, instead of choosing k is equals to 1 and performing the operation 2 times, let's say we are taking k is equals to 2, and when we take k is equals to 2, we can choose 2 numbers. So the numbers we are choosing are 1 and 6. We'll choose both the numbers at the same time, and the cost will be k plus 1, that is equals to 3. And now we have incremented both our numbers and the cost is only 3. So the minimum cost in this case is 3. So 3 is our final answer. For any given array, we have to find So from this example, we have seen that approach 2 is optimal than approach 1, because if we can choose as many numbers as we can in single operation, then we are saving some cost, and that cost is for incrementing. Let's say we have m numbers which have to be incremented. If we increment all those m numbers separately, then let's say we are taking k is equals to 1, and we are incrementing all those m numbers separately. For each operation, it will be taking k plus 1, that is equals to 2, and for all m numbers, that will be 2 into m. But if we take all those m numbers in single operation, let's say if we take k is equals to m and take all those m numbers in a single operation, then cost of that operation will be k plus 1, that is m plus 1. So for incrementing all m numbers, this time the cost is only m plus 1. So m plus 1 is always less than or equal to 2m. So this approach is better. Now let's take another example to get to our solution. Let's say we have 5 numbers: 20, 10, 10, 30, and 5. Now we will start from left to right, and we observe that at, this is index 0, 1, 2, 3, and 4. At index 1, we have found 10, but the maximum until now is 20. So we have to add 10 to this, to index 1. So we will remember that we have to add 10 to index 1. And after that, we will move to second index. And in second index, we have 10 again. To make the array into for this array to be non-decreasing, it should be in this order: 20, and we have to turn this 10 also into 20, this also into 20, and this will be 30, and this 5 also we have to turn it into 30. So even for index 2 also we have to add 10, and for index 3 the number is 30. It is in increasing order, so we don't have to add anything. For index 4 the number is 5. We have to add 25 to this to match it to 30. So we have to add a total of 10 plus 10 plus 25, that is 45. We have to add 45 in total to our array. But how do we add these numbers to the array? So which numbers should we choose, and what is the value of k that we have to choose? So if we choose the value of k is equals to, let's say, 3, and choose all these 3 numbers. So if we choose index 1, 2, and 4, these are the 3 numbers that we choose. And if we perform our operation 10 times, by performing our operation 10 times, then our array will become 20, 20, 20, 30, and 15. Because now these both are achieved. We have got 20, and in here we are only having 15. We still need 15 more here. So to increment this, we will again have to take k is equals to 1, and this time the number that we'll be choosing will be only 4, and perform this operation 15 times once again. After performing this operation 15 times, here we are doing it 10 times. So the cost here is k is equals to 3. So cost is 4 per operation. We are doing this operation 10 times, so total cost is 40. And here we are doing this operation 15, k is equals to 1. So per operation the cost is 2 per operation, and 15 times 2 is equals to 30. So the total cost is 70. See, so this answer for this solution is 70. So to solve this problem, what we are doing is we are taking k as large as we can take, and performing operations to make the number equal to the previous number. Now if we take k is equals to 3, and if we can perform this operation, let's say if we perform this operation 25 times, if we take k is equals to 3 and perform this operation 25 times, then the total cost will be k plus 1 into 25. But only this number has to be only this number has to be incremented 25 times. These two numbers should only be incremented 10 times. So that's why when k is equals to 3, we are only performing the operation 10 times, and when after that we are the remaining 15 times we are incrementing this one. So that is our optimal solution. We will try to look at the pseudocode now once. Pseudocode. We will have our solve method that will be taking the array. So first of all, we will be moving from left to right. So, and while moving from left to right, we have to keep track of the maximum number. Maximum number. So we will take a number prefix max that will keep track of the maximum number until now. We will initialize it to 0. We will have some variable equal to 0, and the sum is the sum of these numbers. This sum number will store the sum of these difference. So we will iterate the array from 0 to n minus 1, and we'll update our prefix max. AR of I. Okay. Now we will find the difference between the prefix max and A of I. That is the difference between these two numbers. So when we are at this point, let's say when we are at this point, in this point, the current max is 20. The prefix max is 20, and the present number is 10. So we have to increase this number by 10. The difference is 10. So to turn 10 into 20, the difference is 10. So that is what we are finding. This is the difference. After finding the difference, we will add the difference to the sum. Yeah. And we will also have, so if we perform this, at the end, what will our sum variable contain? Sum will contain the sum of 10, 20, and 25. That is 45. But the answer is 70, so we still need 25 more. And where do you get the 25 from? So the 25 is for the cost of each operation is k plus 1, right? So what we did until now is this 45 is only sum of k's. So when we are choosing k numbers, if we take the cost of incrementing k numbers equal to k, for let's say for k numbers, the cost is equal to k, then our sum will contain the cost, but the cost that is given to us is k plus 1. So now we have to add that 1, and how many times we have to, this 1 we have to add each time we are performing the operation. So how many operations are we performing in total? In total, we can see we are performing the operation 10 times here and 15 times here. So a total of 25 times we are performing the operation. So we are getting the answer as 70. And what is the 25? The 25 is the maximum difference that we are getting in the array. So we'll take another variable, maximum difference, max diff, let's say. We'll initialize this to 0, and every time we will update the maximum difference. Maximum difference is equals to maximum of maximum difference and current difference. Okay. So in the end, we will just return sum plus maximum difference. This is our answer. So this is our optimal solution, and the time complexity of this solution will be O of n, since we are only iterating the array once, and The space complexity is constant. We are not using any extra space. Yeah, that's it, guys. Thank you.